So hopefully it says live on your end.
Yep.
Sweet. Anyone that's joining, we're just going to give it a few seconds like we normally do. And it's not quite 5 o'clock. I've got my tea.
Good.
Even though it's hot outside.
Yeah. Yep.
And I had my coffee earlier today. I'm a coffee addict.
Yeah, me too. I know.
Yeah.
Like getting pushed later and later that I'm still drinking it. It's really bad.
Yep, exactly. Same with me.
Yeah. I was like, oops, 4 o'clock. I guess I should.
Exactly. It's like, oh, okay. It's time. All right, well, we can go ahead and start.
Okay.
First of all, thank you for joining the YouTube channel here. And everyone who's watching, if you've seen some of my previous interviews, we kind of did a series of actuaries. And the goal is to interview people in different STEM professions, especially those in math type careers. And I knew of Kim Logan because we actually went to Gonzaga together back in the day. And so we both majored in math, and she's working on her PhD. So I thought she'd be a good person kind of in the field to talk about, you know, what you can do in math and kind of how she got to where she's at along her journey. So thank you for joining, Kim.
Yeah, no problem. Thanks for having me.
You're welcome. So my first question to start off, which is kind of similar to what I've asked other people, is like, were you from the beginning, from when you were a kid, good at math? Like, what interested you in math from an early age, or was it kind of later on?
Yeah, no, that's a really good question. I was not interested in math when I was a kid. I was like, when I was really little, I was like really not school focused at all. And my brother was really like book smart, and I was just like more of like a social butterfly. And, like, didn't care about grades or school. And I was particularly bad at math. In fact, I was always put in like siphoned off into like the special kids group that needed more help. And right. Yeah, which was like, you know, it was not my gift for like reading and math. And
see, I always struggled with reading. I was actually kind of slow with math for a little while too, but for me it clicked in like, I think junior high or beginning of high school.
Yeah, exactly. It wasn't until like we started learning algebra that I like totally was starting to get it. I think just numbers still, I don't get numbers. And so, yeah, so it wasn't until we started learning algebra that I like really started to get it. And then they like all of a sudden siphoned us off, and I was siphoned into the other group, and I was like, cool, go into the dumb kids group as per usual. And I looked around, and it was like all of the like best kids in our class. And I was like, where are we going? And they brought us to like an accelerated thing instead. And so I like just all of a sudden transitioned in like 1 year from going to like the slow, you're falling behind group to the like, we're accelerating you group.
Interesting.
And I kept thinking like, when are they going to put me back? Like, I don't belong here. When are they going to put me back? And realize like there was like an alphabetical mistake or something. And they meant to promote like, you know, Timmy Ife instead of Kimmy Klinger or whatever. And like, you know, a couple of weeks went by, and I was just like waiting, like trying to be quiet, like not call attention to myself. And at the end, we were like, they would bring us to the library, and we were leaving the library one day, and the instructor pulled me aside, and I was like, oh shit, now's the time, you know, like now's the time where I have to go back. And he pulled me aside, and I was like, oh God, I want to hear it. He was like, I just wanted to like talk to you. I wanted to let you know you're doing a really, really good job, and like you need to take honors math in high school and all this stuff. And I was like, what? And so, I mean, I think it was hard for me because I was always really bad at standardized tests. And it turned out later I found out I had like a vision problem and stuff like this, but I thought that I was just really bad at it for a really long time. So then high school, I started getting better, and then, you know, I just. Do you
feel like were you doing algebra at the time or something like that when it started clicking, or?
Yeah, definitely. The transition, I think, from doing weird word problems and like number things to like doing algebra and thinking about stuff a little bit more abstractly and logically. I was like, got it
Nice.
now.
That's cool.
Yeah. Yeah.
So like, do you feel like you had a good teacher that really made that click, or do you think it was just kind of maturing, growing up, like your brain kind of started clicking?
I mean, I think partially a good teacher that noticed. I don't know that it was like, I mean, I had good teachers as far as like sort of explaining stuff. But I think it was more like the person that was taking us aside was, he was actually our teacher's like brother. He was an engineer, and he like just, I don't know if he took the semester off or whatever, and would just like come take these kids and do a little math session, like
Okay, yeah,
or whatever. And like, I don't know if it was just that he like understood like different ways that you could be good at math as opposed to just like writing the correct answer all the time. You know, I think it was partially that, and then partially like just like math changed a little bit. Like math got more, you know, like for the algebra and then calculus, I think it got better and better, and it got more conceptual.
yes,
And just stuff that suited me, as opposed to like I'm really bad at like, for me, like I think also my reading comprehension was so bad, and my vision part was so bad that like these long word problems, I like couldn't do it. Like it was too much for me. And so I think just like the type of math changed, and like the more math became like actual math, the more I liked it.
that's interesting. Yeah,
and silly like stupid puzzles, I just was like, this is terrible. But
this is kind of cool to hear, because I was kind of similar in a way.
Yeah.
Where, I mean, I haven't gone as far in math as you have, but like, you know, when I was younger, or I mean, reading was always a struggle for me, and writing a little bit too, but especially reading. And word problems would just overwhelm me. And then once I like learned, how it starts connecting together, I'm like, okay, it started to make sense. But once it got more like in the theory of math and some of the other stuff, I really started liking.
Yeah, when it was just like memorizing times tables and you didn't really understand like why, it was just like it became detached from any like reason why things were happening. It was kind of just like, you know.
Yeah, totally.
So, I mean, it probably was a little bit the teachers too, like as far as like the way they taught. But I think that and I've always thought this, just like in education, there's something really strong about like almost half of your job, in fact, maybe even the most important part of your job, is just like recognizing like different forms of success, and like different, you know, it's like everyone emphasizes different learning styles, but I think like there's also different ways of being good at something, and you know, it doesn't always translate to like, getting the highest grade on a test or whatever. And
I would agree with you. Like, expand on that. Like, what do you mean by that?
Yeah, I have a lot of students that like I can see when I talk to them that they have a way of connecting things and asking really good questions and like connecting concepts and like extrapolating stuff that's like the right idea, but it doesn't always translate to like a numerical value on the exam, you know. And, that's frustrating for them sometimes, but I think part of that is saying, you know, encouraging them that like it's still good, and being lenient and trying to adjust your grading, you know, the way your syllabus is made up or the way your tests are to account for those types of like understanding, you know.
No, I like that.
Yeah.
And like, so what, for you, obviously, like, I know you from Gonzaga, so I know you majored in math, but you had another side of the brain going because you also did art. Is that right?
Sure. Yeah.
Which is crazy. Like, I don't know how you did that. Do you feel like those kind of worked in tandem at all?
Yeah, I mean, I think so. I think definitely, especially the further along you get in math, like the more creative you have to be, thinking of different, you know, ways you can extend a problem, or different types of approaches that other people haven't thought of. Definitely like that type of creativity. I think people think of it as so different, but it's really not. Like I did try to like pursue painting pretty seriously for a while, and after a while it like, you know, like it can become even that like becomes more formulaic, and the math becomes a little bit more creative, and you kind of, you know, like
that's interesting. Yeah.
Between, you know, so I don't know.
Like, actually, this is a question I was going to ask you later on, but I'll ask you now because we're talking about the creativity part. I feel like with math, especially once you get to like higher level math and you're thinking of how to prove things, a lot of times with me, and I'm sure with you, like when I'd be taking a math test, especially like a very proof heavy type exam, it's like proofs like either will like come to you or they don't. Sometimes you have to like think for a long time. Sometimes it's like, oh, I could do it that way. And there's so many ways to do it. Do you find it challenging both as a student and as a teacher to kind of analyze how someone's doing on an exam, especially when it's a proof-based exam, and sometimes those take longer than a given hour or 2 hours or whatever the case may be?
A little bit. I think it depends on how you design your exam, and being a terrible test taker, I just don't think exams should be tricky. Like if you want to take the Putnam or whatever, like fine, you know, if you like that kind of thing, like there's nothing.
I forgot about the Putnam.
Like learning material, I think. There's actual material, like, you know, and content to be learned. And so if there is a trick in proof, or if there is like some sort of really creative idea, like you should have taught them that idea.
Yeah.
You know what I mean? Like I don't know. And so like I said, I don't really. I've taught some proof-based courses, but they're pretty rudimentary, and so I think the further along you get, you kind of see like what is natural and not like so tricky and like wildly like out of the box. Some of the techniques or some of the ideas are, and I think the important thing is to convey that like where it comes from, because also I think sometimes the way we write about math or we talk about math, or like even if I'm writing a paper on a result, like I want to surprise you with something really cool and just be like, oh, this is new and interesting, and like nobody thought of doing it this way, so I present it to you, like, and then I thought of this crazy idea, but that's not what I did. I did these 500 other things first wrong, and they led me to this idea, you know. And so like when I'm teaching, especially classes like that, but all sorts of classes, I think it's really important to like try to translate what's in your mind and what's going on in your mind, as far as like, okay, I have a theorem and I have to prove it. Like, what's the first thing I do? Like, okay, I have to think about what are my assumptions? I'm going to assume those, you know, like, what does this mean? What does that mean? You know, and try to just like go through the whole process out loud, and hopefully they can start adapting the process. And then that comes through in the grading too, you know, like if they're writing out that process, like, maybe they don't get the whole thing, or maybe they're missing some, you know, key point to say, but like they got most of it, you know?
Totally.
Yeah. It's like, oh, it's clear they know what these definitions are, and it's clear they know this, they have to use this other theorem, but like maybe they just didn't see how to put it together, you know?
Yeah.
So I don't know. I feel like it's really easy for people to write exams where it's like, oh, just see the trick, or talk about it like there's some magical trick. But I think that's really harmful.
Yeah.
People's egos.
Definitely. No, I agree with that.
I
feel like most of my exams in school were similar to what you're describing, but I did have a few where I'm like, wow, that like the creativity would have had to strike me during the exam.
Right. And I think that's done for a timed exam. Like if you're gonna get that for a take home, that's fine. But
I mean, that's similar to Putnam, like you said, because I did take the Putnam, and that was just like, whoa, this is insane.
Yeah.
Well, and the interesting thing about the Putnam is I felt like the questions were actually fairly simple. It's like, oh, I understand what they're trying to get at, but how the hell am I going to prove that? I don't know.
How am I going to show that? That's that's a different thing altogether. Yeah. Those are the worst. Yeah.
So what? Kind of going back, you went to Gonzaga. You majored in math. You did art as well. After that, why did you decide to stay in academia, and what was exciting to you about taking that route?
Yeah, that's a good question. I think I remember as like, even in my maybe first year of undergrad or so, pretty early on, I remember just like, I really liked our professors, and, you know, they seemed to have like well-rounded lives, and they seem to be happy, first of all, you know. And I remember seeing that, and seeing them teach, and you know, loving what I was learning, and thinking, man, if you got to talk about this stuff all the time, that'd be so cool. And I think that kind of was like, I saw it and I was like, that's really cool. And I remember sitting down and talking to one of our professors, John Villapando. He was my advisor. And I asked him, like, how did you know you could do this? Or how did you know you wanted to do this? And he said, I just kept going. I decided at some point that I liked this enough that I was going to keep going until someone made me stop. And I was like,
that's awesome. I can picture Villaponda saying that.
Yeah, and I don't know. I think especially as a woman, like that, like I don't know why that was like really. I still remember that. That was like more than 10 years ago. But yeah. I think it really resonated with me because I think, especially as a woman, like we want to tell ourselves to stop. And like, we often think that the world is hinting at us that like, you're done now, like you should stop now, or like, you're not good enough, when it's like, screw that. Like, maybe that's true, but like, if it's really that bad, like if you're harming other people, someone will stop me. You know what I mean? Right. Like if it's done, like someone's gonna make me stop, you know? And so, I mean, maybe I took that too seriously.
Well, I'm actually curious also, like being in math, do you feel like there's a balance between men and women in the math profession? Because I know like engineering, for example, is very heavily weighted toward men just because men tend to be more interested in that. But math, at least I felt like at Gonzaga, we had kind of a split. Do you feel like it's one way or the other?
Yeah, it's definitely, I mean, it is definitely like, if you look at the data, there are definitely many more, you know, men still than women, and it, you know, different stages, it gets worse. So, I mean, they talk about the leaky pipeline, which is like, you know, you start off in say like middle school and it's 50-50 who's interested in math, you know, or whatever. And then in high school, you start dropping some women. Right. But the men don't drop off, the women just drop off for the most part. I mean, you know, obviously men will also drop off, but not like at a very like normal rate or something. Right? But it kind of just goes through like, you know, at college, it might be closer to 50, you know, undergrad, but it just like 100% depends on where you are and what the culture is like. But aside from that, like, I guess in general, and like what level of your, you know, process you're thinking of, whether you're thinking of undergrads or grad school or, you know, academics or, you know, engineers or whatever. And so I think, so I don't know exactly what like the like percentages are in different places. I would say, I want to say probably somewhere around the average graduate program on average is probably close to probably around 25%. Women to men. I think that's like maybe around national average. I have not looked this up, so don't.
I mean, that sounds about right.
Probably not right, but I mean, you can look this up. I'm sure this data is somewhere. And you look at some schools, and it's much less than that. I mean, that's how obviously averages work. We don't. So you know, you look at some schools, and you know, you have 50 grad students, and you have 3 women. Yeah. And you know. But it depends. So my department is, I'm at University of Minnesota, and our director of graduate studies, who is kind of like in charge of admissions and the culture of the graduate students and, you know, all of their affairs, is really focused on trying to get not just a good representation of women in the department as graduate students, but a good representation of American women, which is also hard. So a lot of graduate programs will weight really highly the standardized testing, which you know, statistically Chinese students do much better on than especially American women tend to do the worst out of almost any of the different kind of pockets. I mean, excluding minorities who also do very terribly. And that's another whole issue, but our graduate director has really made a point of trying to do this, and we're near 40% women graduate students.
Oh, wow.
But still our faculty, I mean, it's hard to, you know, it's hard to, I mean, you know, he's been very intentional about creating that environment, and because he's created that environment, you know, the high percentage of women help other women stay there and graduate. You know, I mean, it forms a community. It makes things a norm.
Do you think that's what I'm curious. Do you think part of it is like just because of the difference between men and women, men tend to be more interested in it, or do you think it's because of the fact that it's been like more heavily dominated by males?
Yeah.
That like when a woman gets involved, it's like you don't really have that community like
100%.
that you're talking about.
It's 100% about community and support and what the norms of just all sorts of norms are, like socialization norms, kind of ways of norms and the ways that you work, are all shifted towards like a male dominated culture in like almost every department. And right. I think for the most part, my department is not this way. For like in a very intentionally not this way. But yeah, I think what's really striking about our department is that our graduate program is like 40% women. But if you look at the women who are concentrated as undergraduates, we do have like a financial math that focuses on actuary science, which lots of women do tend to major in.
Yep.
So I think that undergraduates and math majors tend to have a higher percentage than it appears, just because a lot of them are doing the actuarial route, which is not to say that.
I was curious about that, because like being in the actuarial profession myself, I have worked in most every department I've been in at different companies. It's been a fairly even split between men and women. I didn't know like any sort of statistic across, the US or anything, or if it just happened to be the companies that I was at.
Yeah, no, I think so I don't really know. I don't know a statistic either, but a lot of the women that do come in that are interested in math will shoot towards the actuarial route. And I mean, there's a lot of reasons. I have a very strong theory about it that isn't really relevant for most of the world, but like about why our department gets this way. But a lot of what happens is these women will shift towards an actuarial like major, because they'll say, well, I couldn't do research. Like I can't do these things, because they get put in these large classes with really talented, like, or even not even talented, but just very outspoken, overly confident, often men or, other mathematicians that will say, make them feel like they're not doing as well. And they should, they kind of self-select, kind of like I alluded to before, where they self-select and say, I'm not good enough to do this. People are like implying that I shouldn't be doing this when that's not what's happening at all. They're just like weeding themselves out.
Right.
So it's definitely, I mean, it's not an interest, I don't think. So a lot of it is, they kind of start sparsing down, and then the way our upper division classes go, it so happens that once you get to the upper division classes, because the university is so big, they have many sections. There are so few women that oftentimes it will be a class of like 25 or 20 maybe in an upper division class, and there will be maybe two women in that class. And I mean, it's who, like who do you do homework with? Like,
right.
I mean, of course, men and women can do homework together, but like, like your best friends in a different section, like,
exactly. Yeah.
Yeah. So
that's why I was curious about the community aspect. Cause I mean, like you're saying, obviously men and women can do homework together, but in general, it's like, okay, guys will tend to group together, women will tend to group together as like your friends. And then, so it's like, it might be a little more challenging in that regard.
Mm-hmm. And like that part. And then like, even the other men in the class that, just like, there's always like one or two outspoken people that are just like, that like act like they're way smarter than they are, asking all these really intimidating questions, whatever. But like most of the men in the class will just be like, okay, that's that dude, and that has nothing to do with me. But a lot of the women will take that as like, oh, I'm not asking great questions like Jim, so I shouldn't be here, and internalize that as like about them, which is like, in some ways it's almost like ego.
Oh, totally, yeah.
Like not everything's about you.
Yep.
Also, like that's just how a lot of women's brains work, and I've heard it from a lot of them, and I see it happening. And I mean, I'm sure I'm gonna like, I'm sure lots of people are like, you can stand up for yourself, and I totally agree, like 100%. But I hear those words. I hear it every semester.
Yeah, no, I believe it.
Yeah.
Yeah, no, that I mean, that makes sense. And also just as human beings too, we're very subjective when it comes to that kind of a thing, especially like in a class setting, and especially in math. I don't know. There tends to be something about it that I don't know what it is, where people like classify themselves as smart or dumb based on math, which is just, it's not a very good, I don't think people should judge their intelligence that way, but.
Yeah, or even like one class. I think a lot of times, like for some reason, it seems as though a lot of women will take, oh, I got a B or a B plus in this class. That's terrible. I shouldn't be doing this anymore. Where, because like even if it's a class that's not particularly related to anything that maybe they just shouldn't be doing that, that type of thing.
Yeah. And that's the other thing. It's like math is such a broad field too. It's not like if you're good at one thing in math, you actually might not be good at another thing. That's my opinion. I don't know how you feel about that.
Right, of course. But I think, having just taken like general math and when you're growing up and you think like, oh, I'm not good at this class. Like, I'm just not good at math. But that's, like you said, it's so broad. And so I think a lot of guys have an easier time. For some reason, they're more resilient and able to say like, oh, like I didn't get a good grade, whatever, that's just that class, or can write it off as like an insignificant thing when it probably is, where many women will take that as a sign like that they're not good enough.
Interesting.
Yeah.
So at University of Minnesota, though, you have a more like fostering environment to kind of help that, you feel like?
So we're trying to create it like, so, I mean, if you're, this is, I could talk about this all day, so we don't need to spend all time on it.
I could tell you were interested, so I wanted to.
So I have, I've been, last couple of years, been running our Women in Math group, and it's kind of mostly was started towards graduate students and creating that type of community and any other types of, resources that women graduate students need. But we've been trying to extend a lot of our stuff down to the graduate students. And so I ran like a 4-day workshop over the winter where the undergraduate women at University of Minnesota that were interested in majoring in math they would come and, we talked about, classes and job opportunities and all this other stuff. But like the whole guise was like, it's 4 days, you're hanging out with people, maybe you're doing some problem solving, but you're just getting to know other girls that like math. And a lot of them came back and were like, oh, like so-and-so's in my jujitsu class, or so-and-so is in my other math class, or like she's in the other section, but we do talk about, we study for exams, but they never would have known each other.
Right.
So we're doing a lot to try to do it, but it's such a big school. I mean, all that stuff, it takes years. It takes a long time to
believe that.
Yeah, make a difference.
That's awesome, though.
Yeah, it is. It's really cool.
That is very cool. Mm-hmm. So to kind of back up a little bit, this is an interesting.
No, please.
I know we could talk the whole interview about it, but backing up to like your undergrad and your decision, you talked to Villapando, and you're thinking about possibly going the professorship, teacher route. After you graduated from Gonzaga, you decided to were you just thinking, oh, I'm going to get a master's in math? Did you think I'm going to go all the way to PhD? How did that, and did you take a break too? Like how did that transition?
Well, it turned out like when I graduated from Gonzaga, I really wanted, like my last year or 2 years, I really wanted to do Teach for America. I thought it was a really good fit for it. And I put a lot of energy into it, and I didn't get in. And I was like kind of upset. They made the wrong choice, to be honest, but whatever.
Of course they did.
I don't care. I did better.
So explain to people what Teach for America is.
Yeah. So I had wanted to do that, but I ended up at the end of senior year being like, I don't have a job. I don't have any idea what I want to do. So I kind of last minute applied to Eastern and thought, well, I'll, do this or I'll try this and see if I can get through the master's program. And I think initially I thought for a while that community college would be a really good thing for me to teach at community college. There's not the pressure of doing new research all the time. You get to teach, actual college level classes, like linear algebra and abstract algebra sometimes and things like that. And some analysis, and of course calculus and all of those things. But without all that pressure of having to publish all the time and stuff. So I thought that would be a good fit for me. So I thought about doing that. And then after finishing, yeah, I don't really know. It's hard to say exactly what happened. I think that for me, I really just took what John Polifano said so literally. I was like,
just go until someone tells you to stop.
Because, you know, I like started and I was like, well, I'll do a year. I'll try it. Maybe I'll get kicked out. You know, maybe I'll fail out or whatever. And that'll be that. Like, you know, and then I did it. And, you know, I wrote a little thesis and it was mostly just like a summary of stuff. But I was like, I really like this. And like, I'm doing it. And I was like, well, I'll apply. And I mean, nobody lets me in. So I ended up applying I decided I wanted to move to Minnesota to be with my husband, and so I applied to 3 different programs at the University of Minnesota: the math program, the art history program, and the philosophy program. And I did the philosophy program for a couple years because they were the ones that took me. So I studied logic and philosophy of math, which is obviously very related to math.
Yep.
And I decided that was not what I wanted to do long term. And so I took some time off to teach and realized like, nope, I still want to do math. And I just kind of like, in my mind, I think of it as just like, I just wanted to do it. I'm going to keep doing it. Like I applied once, the math department didn't take me. I applied again. They took me the second time after I worked on things and took classes and like, got to know people. And that doesn't always happen, obviously. But when I was in the philosophy department, I took some math classes. I met my now advisor, who kind of vouched for me. And so I think that stuff made a huge difference. And, you know, I think just every step of the way, I'm like, well, I'll try this. And if I fail, I fail. Yeah. That means maybe I shouldn't do it anymore. But, you know, so yeah, I think that was really it. It was like, well, I still like it, so I might as well keep going, you know?
That's a great approach. I like that. So like along the way, you were taking classes and were you teaching it all in your master's and then also when you were doing the philosophy classes?
Yeah, so in my master's in math, so I did a terminal master's in math at Eastern Washington, which they don't offer anymore. And you get accepted with the TA-ship, and that part of that is they pay for, I mean, your coursework that you're taking is paid for. And then you get a small stipend on top of it. I think at the time for Eastern Washington, it was around $14,000 or something. And so you would teach a class a semester or 2 or something like that. I think they had a lot of teaching from what I remembered. It was like 5 days a week.
Oh, wow. So it was busy.
Or something. It was like, but it was fine. I mean, it was fine. It was like algebra. So it wasn't like hard. It was just a little time consuming. Yeah. So you would teach they were on trimester, or the quarter system. So you would teach those. And so I taught through that. When I got accepted in the philosophy program, they also, most of these, especially just pure math and like things geared towards liberal arts, maybe not all of them, they won't accept you unless they're going to give you full funding. So they're going to pay for your classes in exchange for you doing some teaching usually, or maybe sometimes research if you have an advisor with the right funding. So otherwise they just don't accept you because the idea is like, you're probably not going to make enough money to pay us back. And for them, it's, I mean, you know, some universities look at this as free labor or cheap labor. It's not free, but cheap labor. I mean, they all kind of look at it as cheap labor, but some of them are like, well, you know, most of them will only let you in if they want you to be successful, and, you know, and they get a deal out of it as cheap labor.
That makes sense. Yep.
For paying for your tuition. So I've been teaching nonstop basically since I graduated from Gonzaga 10 years ago.
That's amazing. So give people a perspective on, like, let's say they just finished their undergrad and they know they want to get a PhD. Like, what's the amount of time that could potentially, like, what's the fastest versus the longest amount of time that could take someone?
Oh, yeah. Well, so I guess first off, it's best if you can I mean, the earlier you know, or you think you might want to do something like this, the better, because you can do certain things, which I can talk about those too at some point. But you know, you would apply starting in the fall of 1 year, and then you would get accepted the next fall. So,
right.
so you know, ideally you might know at least before your senior year, and you'd apply in your senior year. But you might take a year off, and that's fine. People do it all the time. That's no big deal. For math, it is hard to take like a couple years off or a few years off.
You get rusty.
Yeah, doing that stuff. It's hard.
Yep.
You get a little rusty, but people do it. People do it all the time.
Yep.
And so yeah, you would apply, and then so it's actually different in different countries. So in the United States, most of the time, if you know you want to do a PhD, you can apply for a PhD program, and along the way you'll get a master's. So typically when you do that, you can take anywhere between usually it's a minimum of 4 years. It takes a year or two to get your master's, and then another like 2 years or so to write a dissertation. But that's going really quickly. 4 years, crazy fast.
Gotcha.
Very few people do that. I'd say like 1 in 50, 1 in 20 people do that, right?
Yeah. We're getting the Kim Logan statistics today.
Right. Yeah. Sorry.
25% women in universities. Now we got the 1 in.
Yeah. Well, that's what we do.
No, I'm just kidding. Go ahead.
Whatever. If you just graduated and you still did that, taking 6 years is a very reasonable time period. I'm taking 6 years for this program. Most people will 5 or 6. Some people will take 7, 8 years. Once you start passing 8, it just starts looking weird when you apply for jobs, just to do that full program.
Gotcha.
If that makes sense. But you can do something like what I did. I did a master's at one university that just had a terminal master's, and then I came to University of Minnesota for my PhD. So sometimes if you come with a master's, you can do the PhD part really quickly, like 3 or 4 years. But there is always that like learning gap of like figuring out who your advisor is and getting your research program to do the dissertation. So you can't really even do it in less than 3 years. It's just not.
That makes sense. Yeah. For your dissertation, I mean, do you really have to? I mean, you have to have something new to the field, right?
Yeah. Oh, yeah. Definitely. You have
to
have new results. Yeah, for sure.
Okay.
So it takes a couple years to usually, just get the lay of the land, and even just like figure out. Even if you know the area you want to work in, it's so big, and you probably don't have a problem yet. Like there's just so much to read, get to know your new mentor, advisor, pick a problem, decide what you want to do, struggle, like it.
I believe that. And you probably, I would guess, I don't know, but you probably go down one route and realize, oh, this is not going to work. I'm going to do something else.
Yeah. You make mistakes. You don't just like get the problem, solve the problem.
Yeah.
Sure, you could do it in, quicker, but that doesn't happen typically.
Yeah.
And so, yeah, I think that's roughly the timeline. And it's sort of, I think it's nice to think of it as a choose your own adventure. There's no, I guess like there's not negatives between like, if you want to do it really quick, you can, if that's your motivation, but there's nothing wrong with like getting a master's here and then going somewhere else, or, taking it longer.
So with working on your dissertation now, are you taking any classes as you work on it, or is it like just straight research, straight working on that, and then teaching your classes on the side? Yeah.
So for most programs, you would take your classes only like maybe through the second, third year. It kind of depends the course load that's expected of you. So starting my like 5th and 6th year, I didn't have any classes to take.
Okay. And this is 5th and 6th year, not counting your master's, or counting your master's?
Counting your master's.
Yeah. Okay. Yeah.
Yeah. So yeah, because I like I ended up redoing a master's. So I'm gonna actually have 2 different masters in math now, which is
weird.
Really?
No way.
Yeah.
Okay.
Yeah. So because it's kind of dumb. Just that like usually it's like if you're going along with a PhD, there is this point where they're like, you have to take an exam to like be able to work on your dissertation, and they're like, do you want the master's? And you like all you have to do is like check the box. And you're like, well,
You're like, yes.
like, at least I have something from all this time I spent here. I don't know.
Yeah.
So whatever, I check the box. This master's is better than the other master's.
Yeah.
So I don't know. I like checking boxes. You don't have to. It's just everyone's like, why wouldn't you just do it?
Yeah.
Yeah. So So I know, I'm like, oh, this is so confusing. So I'm not taking classes, but usually in your 5th and 6th year when you're in dissertation mode, I do, like when my advisor teaches a class, I usually sit in on it and I'm not taking it for a grade. And I've seen the things before, but it's nice to see them again. Or if someone's teaching a special topics class, I'll sit in on it. Just
okay.
There's also seminars that will happen usually weekly. Like I organize a student seminar, and then like my advisor has his own seminar that I go to. So, which is essentially like taking a class. You know, you go and you hear talks or you give talks or whatever. And then depending on, last year I was teaching during the semester as part of, again, like it's still like, you would still have to pay because I still have to register for credits when I'm in dissertation mode because, you know, the university, they want their money, whatever, right? Even though like literally like I'm doing all the things, like there's not even like people here, like, what are you doing? There's no classroom. You're not paying for the classroom. There's no instructor. So yeah, I still have to register for credits. So the university still pays for those. You know, they still pay me my health insurance. By the way, you get health insurance.
Oh, that's really pretty cool. That's
fabulous health insurance.
That is great.
Yeah, especially if you go to a really good school, like University of Minnesota has a fabulous medical school, like the Mayo Clinic is attached to University of Minnesota. So
nice.
Amazing healthcare.
That's awesome. And behind the scenes, you've got actuaries that are pricing that.
Yeah.
For the school to pay.
Yeah, it's great. So dental.
Nice.
It's fabulous. I'm never leaving. So I still have to, you know, do that stuff, like teach in order to get, you know, my benefits and to get paid and all of that stuff. And then this coming year, I have a fellowship. So you can apply for fellowships and other money so that you don't have to teach, but you still make a stipend and they'll still cover your health care. Okay. So you can, it's basically just an award for saying like, hey, it seems like you're doing pretty good research. So let's make sure you have enough time to do it.
Right. Yeah. So for those people that are like thinking about going this route and they don't have tons of money saved, can they make it through from like starting with their master's, going through PhD, without getting any other side job, or is that going to be tough? Like,
100%. Most people don't. And you really probably shouldn't because you really don't have time. Even though I know what I just said sounds like literally you go for like 2 hours into school a week. It's what it sounds like I just said, but that's not really what's happening.
No, I know.
Yeah. So I know it sounds like, well, that's like, we're giving you money for what? But no, you don't really have time for another job. Almost no one does. If you need a little extra money, there's things like teaching in the summer. You know, you don't have anything you have to do research. I'm not quotes. You do have to do research. You have to do things, right? In the summer,
some fake research.
But you have to do stuff in the summer, but not like anything, you know, time specified. So most people will teach in the summer, extra classes. You can do tutoring, things like that. But I mean, at some universities, I'm sure certain people do take on jobs like bartending or working at a coffee shop, but you should talk.
It's a lot, yeah.
Yeah. Yeah. Especially like it will usually mean you will take longer, which is just not a good idea.
Totally.
Yeah.
That's cool. So going to your dissertation, can you give people a brief summary of, I don't even know if I can say it, zeros of L functions and self-adjoint operators, or maybe it's the other way around.
Yeah.
Can you give a summary in a very like simple way what you are doing? Yeah.
Okay. So I knew you were going to ask this, but I didn't.
Of course I am.
So I'll try to be very quick because I know probably.
I'm sure you could talk for days on that. You've been researching for years.
Right. Okay. So there's this huge. So lots of. I feel like if you can't attach your problem to at least a big open problem or something obviously relevant, you either don't know what you're doing or like you really need to think about why you're doing it.
Yep.
So there's this huge open problem. It's called the Riemann hypothesis. And Paul, you probably vaguely remember this.
The what hypothesis?
The Riemann hypothesis.
Oh, yeah. Yeah.
So you might have heard of it, the name at least, because there's $1 million attached to solving this problem.
Yeah, I remember there's like a whole list of problems that are like that.
Right. The Clay Institute put out a list of, is it 8 or is it 10? I think it's 8.
Because I remember trying to solve one, like there was a graph theory one, and I remember sitting down, I'm like, I think I could solve this. I'm like, no, I can't.
Yeah, they're really hard for a reason. It's good to do. It's a good mental exercise. So think about why they're hard. The Riemann hypothesis is one of these problems. And basically what it says is you have a complex valued function. So it takes complex numbers, like things of the form a plus square root of negative 1b, right? Mm-hmm. It takes complex numbers to complex numbers, and it's written as an infinite sum. And this function is special because it was shown by Riemann in 1859 to have a deep connection with the distribution of primes throughout the integers. And so if you're thinking of, if you look at the primes, okay, you look at 1, that's not a prime. We just ruled it out. We said it wasn't because you don't like it. Okay, so 1, 2 is the first prime, 3 is the second prime, 4 is not a prime, 5 is a prime, right? 6 isn't a prime, 7's a prime, 8 isn't a prime, 9 isn't a prime, 10 isn't a prime, 11's a prime, right? So you look at how they're spaced out, right? And it looks, you start writing them out and they look super unregular, right? Because there's like, it starts with 2 next to each other, and we know that never happens again because if there were 2 next to each other, one of them would be even, and the only even prime is 2, right? So they're super weirdly spread out, right? And so this is like a problem we really care about with how, where's the next prime and how many primes are there below a particular number, right? Like if I look at 10, how many primes are there below 10? I think we said there are 4, right? 2, 3, 5, 7, right? So this function that says pick a particular number, how many primes are there below it, is directly tied to this Riemann zeta function that's a complex value function. And the zeros of this function,
you're like bringing me back to number theory. I remember discussing this some.
So the zeros of this crazy Riemann zeta function, which already doesn't make sense, right? I'm talking about primes distributed throughout the integers, and then I'm looking at a complex valued function. Like we were just talking about integers. Why do I need complex numbers? That seems weird.
Yeah.
Okay, fine, but should do. So this Riemann zeta function, if you look at where the zeros are, if you have a complex plane and you take all of the I imaginary units and all of the real units, like the complex numbers you can graph on a plane like this. Riemann's hypothesis, oh shoot, I don't know which way I'm mirrored with the camera, but Riemann's hypothesis says that
your elbow is on the right side. For me.
Okay, so the Riemann hypothesis says that all of the zeros of the Riemann zeta function are on this line real part equals 1/2. So I could draw a picture and that would probably make more sense.
By the way, while she's drawing that picture, anyone who does not know what complex numbers are or hasn't taken some of these math classes, there's the a plus bi thing she was talking about. A is a real number, which can be how do you represent real numbers? They can be integers, or they can be have any infinite number of decimals, like real numbers that we would think about. And then I is the square root of -1. So a plus bi is kind of representing an all-encompassing representation of what they call complex numbers. And then when she's graphing it like this, she's saying the complex are on 1.
Yeah, so when I'm graphing it, I'm saying like, okay, I can mark any complex number as just a dot in this plane, a plus bi, where a and b are real numbers. And so if I think of this as a real axis, and then this is the imaginary axis, like square root of -1 times any real number, then any complex number is on this plane.
Yep.
And the Riemann hypothesis says that all of the zeros of this crazy Riemann zeta function lie on this critical one. And so this problem, so basically Riemann stated this as a hypothesis in 1859 when he wrote this paper, and he said it in passing, like he even wrote down some of these zeros. He thought he like tried to solve it and thought like, oh, I don't know if he was like, I'm too tired today, but he was like, I think this should be easy enough to show, done, right?
He actually wrote that. This should be easy enough to show.
Something like, he wrote something like that. Like, this is true, but like, can't prove it right now.
Yeah.
So we still haven't proved it. It's still an open problem. And so we thought of all different ways we can try to solve this problem. And there are kind of like a few different theories and camps as to like different approaches that you can use to solve them. And one of them is operator theory. And the idea is, if I take a particular operator, so like taking a derivative, it is an operator. It inputs functions and it outputs other functions. It operates on functions. If I take a particular operator and I find the eigenvalues of this operator, and those eigenvalues match up with the zeta function, I can prove the Riemann hypothesis this way. And so this idea was kind of hypothesized by Hilbert and Poya when like a long time ago. And so I just work with different types of operators, and they work on weird function spaces and, you know, take all sorts of weird values and work with all sorts of weird number theoretic junk. But basically what I try to do is work with those and figure out how to correlate zeros of particular functions, like say the Riemann zeta function, and figure out how they interplay with eigenvalues of operators. That's
interesting. Big. Okay.
So
I'd have to refresh on eigenvalues. I remember differential equations. I remember using those.
Yeah. So there's a big hint. If you want to go to grad school, definitely linear algebra was important. Apparently, like the most important class that you took in college, but she just slept through because it was so easy at the time. And, you know.
Yeah, exactly.
So cute, so you weren't really paying attention. But
we did eigenvalues in linear algebra too. That's right.
Yeah, exactly. Yep. So those are extremely important.
Yeah. Nice.
Mm-hmm. Yeah.
This is I don't know why I thought of this when you were talking. This is really random, but one time this is actually when I was at Gonzaga. I thought about this, and I don't know if there's any pattern to it, but like take what was it? If you take 10 squared, you get 100, add the digits, and it's 1 plus 0 plus 0 is 1. 11 squared is 121, add 1, 2, and 1, you get 4, which is a perfect square. 12 squared is 144, 1 plus 4 plus 4 is 9, which is a perfect square. 13 squared.
I feel like there might be like something tied to this, like a little number here.
So I tested it. Like, I don't know. I remember thinking about it one time, and I tested it. It eventually fails, but I'm like, there's got to be a reason, because for quite a while you get perfect squares.
Yeah.
And I don't know why that is.
Yeah.
I don't know why I thought of that, but that's just a little random math thing.
To all of your questions about the numbers.
Yeah. You're like the math genius. I want to know everything.
Definitely not.
Yeah.
I know the answers about the when specific thing that I do.
Yeah. So it's self-adjoint operators and zeros of L functions. Okay. Yeah. So if you figure out what you're figuring out, is it going to help with anything in like cryptography at all, or with prime numbers?
Right. So, I mean, that's the idea, definitely, is that if someone solves the Riemann hypothesis, we know the exact distribution of the primes throughout the integers, and knowing, like, having that information, like, I mean, RSA is
right.
Like, lots of things are just kind of like all sorts of encryption that we have is kind of like no longer working. So it's cool because we know, like, you'd be able to, you know, crack a bunch of these codes and stuff, but it's also like security would be
totally.
Yep, I think I figured other things out, so I don't know. I don't follow it too closely, but yes, there is a definite tie between. So
do you have like a certain amount of time left that you know until you finish, or is it still kind of unknown at this point?
Yeah, I'm definitely finishing in the spring. Yeah.
Okay, nice.
Yeah. So
exciting. And is your future is like you want to teach? That's kind of your goal with the PhD.
Yeah, my future. Well, no one knows. I don't know what my future. But my future is that I would like to eventually get a tenure track job, go into academia, teach and do research.
That's awesome.
Yeah.
So now give people a little comparison of teaching versus research. What's more exciting to you?
Oh God. I think it sometimes depends on, I think it really depends on what point I am in my life. I think when I went into this, I was like, I love teaching so much. And I still really like it a lot. It just kind of depends. It just depends on the day of the week sometimes. But
that's understandable.
It's a good problem to have, I think.
Yeah.
I thought that going into it, I wouldn't really like doing research. I thought I'm going to be so bad at this and I don't like ambiguity and lack of control. But it turns out basically it's not as bad as you think it's going to be. Even though certain things are ambiguous, like you do, I think for me, before I thought about doing research, I thought it was like this big open, like, oh, someone, there's a theorem that's sent down from the heavens and you have to prove it. Like, because that's how classes are. There's a theorem in your book and then you just have to prove it. And you're like, what? And it was like, there's a theorem and then like, but where's the book? Right? Yeah. So I'm like, is the book the internet? It is not the internet. You cannot Google research. It does not work for
what?
anybody. I know. I've been there. It doesn't. So the idea is that it's not really like that. It's like you read some stuff that's interesting to you and you figure out where like you could maybe make something a little bit better, or where there's like where you could apply it to something else or whatever, and so that's where a lot of that creativity I think does come in. And so often, you're working on something and you're like, man, it feels like this should be true or something like this, but it's just not working. And maybe it's because it's not true. And you just change what your theorem is. Yeah. So it seems like this big open, like, like, how do you prove the theorem? Yeah. And it's not really like that. It's just that you investigate stuff like you think you would, right? You're trying to learn things and you're trying to understand it and you're trying to like explain it to somebody. And in doing that, you're like, oh, it turns out this other thing happens sometimes. Or like, oh, I thought this would happen all the time, but it doesn't in this one really weird case. And like you curtail it and you change your theorem and that's your result, Yeah. And so, that's really fun because I do like that kind of problem solving. I don't like problem solving like what is the, like multiplying the largest numbers I can in my head, I like trying to like figure out like, what's the optimal way to do this or, trying to understand stuff. And so,
and that's where like, I think so many people that haven't taken a lot of math classes think about that. Like, oh, you can't multiply 567 times 839 in your head. Yeah. Like, but like there's so many more cool things in math that is very like, and can be applied to a lot of things. Some of it maybe can't be applied or maybe applied in the future, but like it's very logical. There's a lot of like really cool stuff to think about other than just not like adding multiplying numbers together. So although I think we have a fairly mathematical crowd that will watch this anyway. But if you're not mathematical, then yeah. I'm also curious, for those who don't know, she married another math guy at Gonzaga. I'm curious, do you guys talk math at home at all, or you just like try to avoid that?
Yeah, no, totally. We have tailed it down significantly over the years.
You're like, all right, this is too much.
Mainly what happens is you each get in your specified area and you know more about it, and then you know more about your thing. Yeah. And I haven't read all your literature and you haven't read all my literature, so it's just like, what's this again? What's the Riemann zeta function? What's this? And so no, mainly that happens, but actually we do talk about math probably way more than anyone would think.
That's what I was wondering.
Yeah, because actually what happens for both of us, and I think for a lot of people, is just like you run into a problem and like usually you can at least like you're like, I can't figure out how this goes, or like why this works or whatever. And you can usually put it down. Like it really is so helpful to try to put it down to like the basic logical pieces, or like, what is the bare minimum I need for this, you know, and to try to like sit down and then like figure that out and then try to explain it to someone else. Like even if, you know, he doesn't know exactly what I'm talking about, he'll be like, wait, why did you do that? Wasn't it a 2 before, you know, or what? And he's like, oh, you know, there's a surprising how many times that was really helpful.
Oh, yeah.
You know, I mean, I think what he does is, you know, fascinating and valuable, and he thinks what I do is, well,
that's awesome.
Or well, I think what I do is fascinating.
That's also like, it's like a good way to kind of process things too. Like, I mean, I even find like when I talk to people at work, there will be something that I'm stuck on, and then I start saying it, and then as I say it, I see what the problem is. It's like, oh, that was like, you know, simple little thing.
Yeah, typing up an email or something with a question, and all of a sudden you're like, oh, like once I made stuff clear enough, you know.
Yeah. That's cool.
Yeah.
Well, we're getting to the top of the hour, so I just have 2 more fun questions for you. I'm sure we could talk forever, so we'll try to wrap this up.
Either of them are multiply these 2 large numbers.
Yeah, exactly. First question is multiply. No, I won't do that to you. I won't do that to you on YouTube Live.
My iPhone. No.
Yeah, exactly. What's your favorite trip you've done in the last 10 years?
Oh God, trip, like physical trip?
Like trip, yeah. Like where favorite place you visited?
Oh, that's really hard. So my husband and I just took the whole month of June and traveled because I had a conference in Bristol at the beginning of June and a conference in Bonn at the end of June. And I mean, this trip was probably, I mean, I've been to Europe before, but this trip was probably my favorite. I don't even know. We went 2 places that it's hard to even compare. We went to Sardinia, and which is an island in the Mediterranean. It's part of Italy, and it's very uninhabited, which is amazing. And we rappelled down like these rock cliffs over the sea and then climbed back.
Oh, no way. That sounds amazing.
It was amazing. And we kayaked all through these like caves and stuff. It was beautiful. And then we also went to go and hike through the Alps. I'd have to say the Alps.
Oh, I am jealous. That's a place I really want to go.
It was amazing. We drove out to Zermatt, and then we like hiked all around the Matterhorn, and it was just insane.
That is incredible. Like all the pictures that I see like on Instagram and all over the place, like Switzerland,
so worth it.
Has to be like the most beautiful. I haven't been there, but I want to go there.
Yeah, it's so worth it. Oh my God, the Alps.
That's cool.
Yeah, it's so amazing.
Nice.
Yeah.
My second question for you is, let's hear your favorite in-class story, whether it's as a teacher or as a student.
Okay.
This might be a tough question.
This is the first one that comes to mind. It's probably my favorite. So it's not. So I had this, so I was taking this grad class. I think it was my first year. Yeah, it was my first year at Minnesota. It was a graduate real analysis class that a bunch of the first and second year students had to take, and it was pretty full. And usually there's a couple undergraduates that will take these classes, which also if you're an undergraduate at a large research institution and you're a student going to grad school, try to take their graduate level classes, like for a lot of reasons.
Yep.
But so there were a couple undergrads that were in this class. They're really, you know, nice kids, real smart and talented. This particular one, just really annoying. So he would come to class every day and sit in the back. The class was like packed, and so he would sit in the back. And I remember the first class, he was really annoying. Like he was sitting behind me, and like everything the professor would say, he would say something, and he'd be like, oh, "Okay, that's interesting. Oh, that's this. Oh, that's blah blah blah." Like that's, you know, like we're all dumb. Like we all have this. Like everyone else in the class like knows the same thing. You know, it's like the first freaking day. You know, we all know this.
Right.
Like, he was just like saying it under his breath, like, "Oh, like I'm so much smarter than all these grad students. Like I know what all this stuff is already." And it's like, oh my God. So he would do this and like, and it was like, I don't want to listen to you. I want to listen to him. You know, I came here for him, not for you. So, but he would come to class for most of the rest of the semester. He would come to class every day, and he'd get there a little bit early, and he'd come with a physical newspaper, an actual newspaper, not reading the news on his phone, like we all normally do, a physical newspaper, and he would sit in the class with the newspaper wide open and read, and just like,
no way.
You know, like, not even like folded neatly, like, oh, I'm reading, you know, I'm doing the crossword, like here. No, boom. And so he would sit, and it just like flapping it, you know, like a grandpa or whatever. And so he would read the newspaper in class every day. And finally, at the end of the semester, so this professor I love so much. I think he has, well, it's a love-hate relationship, but he is so funny. He's a really great mathematician. He does PDEs, went to Princeton. He's brilliant. But he's also really into hockey. And he played a lot of hockey, and he looks like he plays hockey. Like, his neck is like bigger than my shoulders, you know, and he's like probably 6'3", like, you know, 200 something pounds, like pretty much just muscle and like huge neck and just like really kind of Germanic, like really intense features, you know, and it's like, if he's smiling and happy, it's like, oh, he's a nice bear. If he's not smiling, it's like, oh like, my God, one hand, you know, he's terrifying. And his personality is very much like this. Like, sometimes he's really giddy and goofy and like a little kid and like really sweet and nice and funny. And, you know, you just want to bear hug him. And then sometimes it would just be like, oh shit, like he would murder us all. And so anyway, this guy would come and he would read this newspaper, and we were all so annoyed. And so the professor, he's like talking at the front of class, first few minutes, he's saying stuff, and all of a sudden he's silent. And he puts down the chalk, and he turns around, and he says, you know, one day, you know, this is all fine and whatever, but one day you're going to go into a class, and the professor is not going to be as nice as you. And they're going to look at you, and they're going to see that, and they're going to ask you to put the goddamn newspaper away. And he's just like,
God, you just like freak out.
And everyone was like, shit. And like, don't turn around. And apparently, like, he like folded up the newspaper, put it away, and like never came back to class. Wow,
wait, that didn't happen until the end of the semester, though?
I think it was like, it wasn't like the very end, but I think it was well into the semester. Like, he just like, you could tell it was like, he was like, I don't want to like be nitpicky. Maybe he won't bring it next time, kind of thing. Yeah. But he just like all of a sudden was like, I fucking can't take it. And it was so funny. And so he now puts that in his syllabus. If you read the syllabus, like all of his classes say like, you know, please do not bring a newspaper.
You have to like warn everyone now.
Yeah.
That is hilarious. Oh, I wonder what the kid was, if the kid was just like trying to make some point, like I'm too smart for this or what?
I, you know, don't care. It's like, just don't come. Like,
yeah, exactly. Yeah. That is hilarious.
Yep.
Well, good story. I think now we're at the top of the hour, so I appreciate your time. That was very interesting. I'm sure we could talk for a lot longer, but I hope this helped anyone who's watching on route to be a math PhD.
Yep.
So thanks again. And Kim is out from Minnesota. I'm out from Coronado.
Okay. Bye.
Talk to you later. Bye.